Hi everyone, in this video we are going to discuss the Cauchy's integral theorem, which is a central statement in complex analysis in mathematics. It expresses that a complex function defined on a disk is determined entirely by its values on the disk boundary. For all derivatives of a complex function, it provides integration formulae. In this video, you will learn Cauchy's integral theorem and the formula with help of the particular sum. Before going to the theorem, let us understand what a simply connected region is. Simply connected region. A connected region is called a simply connected region if all the interior points of the closed curve that are illustrated in this region and they are also the points of the region. That is simply connected region. You should focus on this specific method in all levels of questions for main exams as well as other competitive examinations. Let us get into the details. What is a Cauchy's integral theorem? If the complex function f of z is analytic and the first derivative to the complex function f of z is continuous at each point inside and on a closed curve C, then integral over C f of z dz is 0. Here, this integral symbol is called the contour integral. F of z is analytic function. Mainly, the first derivative to this f of z is continuous at each point inside and also on a closed curve. Then we have the result integral over C f of z dz is 0. This is very important for all competitive examinations as well as main examinations. Now we have to verify the Cauchy's integral theorem for the function f of z if C is the boundary of the square bounded by the lines z equals to plus or minus 1 and z equals to plus or minus I. Without actually getting to the details, we can easily say that Cauchy's integral theorem to the function f of z is verified since f of z 3z square plus iz negative 4 is algebraic function. First derivative to f of z, f dash of z is 6z plus I. That is again algebraic function which is continuous everywhere, so that the complex function f dash of z is continuous within and on a closed curve C. According to Cauchy's integral theorem, integral over C f of z dz is 0. But it is given for 8 marks. We have the proof. Let us get into the details. Here we are given that the complex function f of z 3z square plus iz negative 4. Let C be the square bounded by the lines z equals to 1, z equals to negative 1, z equals to I, z equals to negative I. Z equals to 1 means x is equals to 1. Since we know that the complex variable z x plus iy is equals to 1 plus I0. By comparison, we have the real part x is equals to 1, which is only the non-zero value. Z equals to negative 1 means x is equals to minus 1. And proceeding in this way, z equals to I means y is 1, z equals to I nothing but y is negative 1. Here the vertices of the square negative 1, negative 1, 1, negative 1, 1, 1, negative 1, positive 1, which represents a square. Our main objective is to show that integral over C f of z dz is 0. Let us consider integral over C1 fz dz plus integral over C2 fz dz plus integral over C3 fz dz plus integral C4 fz dz, where C1 the line AB, where C2 the line BD, C3 line DE, C4 line EA. We have integral over C f of z dz is the integral over C 3z square plus iz into 4 dz. We know that the complex variable z is x plus iy, then dz is dx plus idy. Let us consider along the path C1. So here AB is the fixed line, that is y is equals to -1, x vary from -1 to +1. When y is equals to -1, dz is dx, since z equals to x minus I. Therefore, integral over C1 f of z dz is integral -1 to +1, 3z square becomes 3 times x negative I square, since z equals to x negative I, plus I times z is x negative I, -4, dz becomes dx. On simplification, the integrand is 3x square negative 5ix negative 6. Here the both limits are same, having opposite signs. Now you need to know even and odd functions. Only x square and the constant are even functions, x is odd function. We know that integral -a to positive a f of x dx is 2 times integral 0 to a f of x dx, while f of x is an even. It is 2 times integral 0 to 1 3x square negative 6 dx. The rest of the part is 0, since x is odd function. 2 constant 3x square, its integration x power 3, 6 integration 6x. Consider the limits between 0 and 1. On simplification, just we have obtained 2 times 1 negative 6 negative 0, it is negative 10. That is the integral over C1 f of z dz, where C1 is the line AB. Coming to integral over C2 f of z dz, along the path C2, that is line BD, here it is a fixed line, x is equals to 1, then dx is equals to 0, y vary from -1 to +1. Therefore, integral over C2 f of z dz is y vary from -1 to +1, z is x plus iy, but we convert this integrand in terms of the variable y, while x is equals to 1. Here the integrand is the 3z square plus iz negative 4, should be this expression. Just we have substituted x is equals to 1 and we have obtained this. We have the definite integral -1 to +1 on simplification, which is the revised integrand, integrate with respect to y. Just we can apply integration to this particular integrand with respect to y. We have obtained this result, and consider the limits between -1 to +1. We have obtained -2, -5i by 2, negative, the lower result is 0 plus 3i by 2. On simplification, -2, -4i is the result of integral over C2 f of z dz, where C2 the line BD. Coming to integral over C3 f of z dz, we have the third path C3, that is DE. Here it is a fixed line, the line is y is equals to 1, then dy is 0, x varies from 1 to -1. Therefore, integral over C3 f of z dz is integral 1 to -1. The integrand 3z square plus iz negative 4 becomes this expression after substitution of y is equals to 1. On simplification, the revised integrand is this thing, and integrate the integrand with respect to x. We have x power 3 negative 8x plus I times 3x square by 2. Consider the limits between 1 and -1. The upper result is negative 1 plus 8 plus 3i by 2 minus the lower result is 1 negative 8 plus 3i by 2. On simplification, we have obtained 14 as the result of integral over c3 f of z dz, where c3 is the line D. Coming to integral over c4 f of z dz, where c4 is the line EA. Along the path EA, that is the fourth path, it is a fixed line x is equals to minus 1, which implies that dx is 0, while y varies from 1 to negative 1. Therefore, integral over c4 f of z dz is integral 1 to negative 1. The integrand 3z square plus iz negative 4 becomes this thing when x replaced with negative 1. On simplification, we have the resultant integrand and integrate with respect to y. We have this is the result required and consider the limits between 1 and negative 1. On simplification, we have 0 plus 3i by 2, negative 2 negative 5i by 2, that is negative 2 plus 4i. Therefore, integral over c f of z dz is the sum of all the 4 line integrals. The result will be 0 on simplification. Thus, integral over c f of z dz is 0. Hence, we came to conclude that Cauchy's integral theorem is verified.